Howdy, folks. What we're going to start talking about today is a subject in calculus that is related to physics. In fact, you may be interested to know that that the subject of calculus was actually partially formalized by people who were scientists in physics. In fact, Isaac Newton was one of those people. You know, the subject of calculus was actually partially developed by Isaac Newton, who also studied physics and the motion of objects. And so that's what we're going to talk about today. We're going to talk about, in fact, not just today and in the next class and in the third class, we're going to talk about different aspects of how we can use calculus to understand what is called object motion. When I say object motion, I'm talking about when an object is moving through space, moving up and down, left and right, backwards and forward, as a juggler juggles balls, or as a bullet travels through the air, or as a cannonball travels through the air. Lots of different things. And eventually you can understand how light particles move and how, well, basically, just about any kind of matter, how it moves. You can use calculus to understand these things. Now, the reason that I'm at the back of my classroom and the reason that I'm kind of far away right now is because I want to explain to you that the way we begin to understand object motion with calculus is through the study of something called rectilinear motion. Rectilinear motion. Recti meaning like rectangular coordinates, linear meaning straight line, motion meaning the object is moving. Okay? So here's what you have to understand. So the floor right here is kind of a grid, which is really useful. It can help us to understand. You probably can't see the grid of the tiles very well, but I'm going to try to explain it. We live in the third dimension, which means that our physical bodies and the things that we interact with have three bi-directional dimensions that we live in. We have the x-axis, which goes left and right. We have the y-axis, which goes up and down. And then we have the z-axis, which goes forward and backward. And when an object moves, it can move along all three axes. When we walk around the room, or any room, when we walk around, we usually only move around on two of the axes. We move around on the left, or the left-right axis, and the forward-backward axis. We don't really move up and down. But when we sit down in a chair, our head, right, actually changes its vertical position. It goes from up here down to here. And then when I stand up again, my head is moving vertically, as are all the atoms, especially in the upper half of my body. Okay? So, when an object moves, it moves through three-dimensional space along the x-axis, along the y-axis, and along the z-axis. So, when a pen goes flying through the air, it's moving along three dimensions. It moved from here over to here as it went up like this, right? So along the x-axis, it moved this way. Along the z-axis, it moved this way. And along the y-axis, it did this. It went up and then it came down, okay? So those are three distinct axes of motion. In rectilinear motion, we only look at one of those three dimensions at a time. We are only going to examine motion either along the x-axis, or along the y-axis, or along the z-axis. And we're going to investigate this motion along a single axis over time. So now time becomes a fourth axis. It becomes a fourth dimension over which we investigate this motion of the object. Okay? So what I'm going to do now is I'm going to go up to the board and we're going to try and look at how we can graph, how we can model the motion of an object on a single axis. Okay, so what we're studying here, what we're going to learn about in some fields is called kinematics, which is the motion of an object, okay, kinematics, or in calculus, we're going to call it rectilinear motion. And so here's what's going to happen. Let's say that we have an x and a y axis. Here's the x-axis, and here's the y-axis. And then we can model the position of an object based on its vertical dimension and its right-left dimension. Okay? So typically what we'll do is, like in a physics class, you might see a cannonball that gets shot up into the air and then it comes down and lands over here. So it's moving sideways along the x-axis and it's moving up and down along the y-axis, right? Well, what we're going to do is this, is we are going to turn this sideways, okay, so that now we have the x-axis up here and the y-axis is over here. We've turned it sideways. And then what we're going to do is we're going to add on a third axis. So say we have this, and we're going to add on a third axis that is now sticking out, right? This is going to be the t-axis. So this is the t-axis. So we have 1 dimension, 2 dimensions, 3 dimensions. So as time passes in a positive direction, the physical location of the object is changing its position as it comes out along the t-axis. Okay? So now, but what I want to do is I want to model using the t-axis. So I'm going to take the t-axis and I'm going to turn it this way so that it's right here. And when that happens, when the t-axis turns this way, the y-axis is going to swing out, and we don't need the y-axis anymore. And so now what we have is just the x-axis over time. All right, so put this back over here. So we've got the time axis here. And what we do is we model the movement along the x-axis. And by the way, here's the deal. If the x-axis goes left and right, so it's motion along this axis, left and right, okay? We have to understand that there's an origin point. So wherever the middle is, and it's arbitrary where you choose the origin point, but any motion along the x-axis to the right is positive motion. Any motion along the x-axis to the left is negative motion. And here's how it would look on here. You almost have to turn your head sideways, but really you should be on the other side of it. Okay? Or maybe you can turn it this way. This is rightward motion, and this is leftward motion. Right and left. And it's happening, it's being mapped over time. Okay? So, rightward motion, this is the right, the positive side, that's movement to the right, and the negative side, that's movement to the left. So whenever the object moves to the right, it's going this way along the x-axis. And if it's over there and it turns around and comes back, then what it did is it turned around and came back. Then if it moves over there to the left, it's going to be moving over here. Then if it turns around and comes back, it's going to turn around and come back to the origin. Okay? So what that would have done was it would have gone here, then turned around and come back, then here, and turned around and come back. But because it can't be in the same place at every time, let's say over several seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Let's say after 1 second, the object is a little bit to the right. Well, we would graph that by putting a dot here. Then let's say after another second, it's a little bit farther, but not a whole, let's say it's right about here after another second. So that means it would be here. Then what if it's slowing down and it went to here after another second, and then it stopped, and then it came back. Then after 4 seconds, it's now moving backwards. It turned around and came back. So after 4 seconds, it's here. And let's say after 5 seconds, it gets back to the origin, and it's down here. Okay? So over time, this is what the graph of that object would look like. And then let's say that it turned, or that then it went left. So then it's down here, and then it continues, and then it turns around, and then it keeps going and comes back to the origin. And so then it would look like, this would be a graph, this would be a graph of the motion of the object along the x-axis over time. And if we were able to identify a function for this graph, like, and here's how we would write it. This is the position of the object relative to the x-axis. The position is right, but farther. Then it turns around. Then it's still to the right, but it's coming back. It's getting closer and closer and closer. See, look, this is the distance. This vertical line represents the distance along the x-axis to the right. And look what's happening. The distance is getting farther. It's getting longer because the object is moving away from the origin until it gets to a place where it is farthest away. It turns around, and in order to turn around, it has to stop and then turn around and come back. And now its distance is getting shorter and shorter and shorter until the distance away from the origin is 0 and it arrives back at the origin, then moves in the leftward direction, goes farther, farther, farther away, then turns around and gets closer, 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 and then back to the origin. Okay? This up, down, up could be, let's say, a sine function. It could also be a cubic function. But we can draw this as a function, x as a function of t. The position, the x position over time, which would be x of t. That would be our function. And we can make this any function. We could make it an exponential function. We could make it a sine function, any kind of trigonometric function. We could make it a polynomial function. We could make it a square root function or a logarithmic function. We can use any kind of function. And what I'm going to do in this video is I'm going to show you how to answer questions about the motion of this object based on a function that represents the position of this object. So here's what I'm going to do. I'm going to break for just a second, and I'm going to put a function up here that represents the position of the object, and then we're going to answer about 5 different kinds of questions. All right, so here's what I've got. I've got these 5 questions here that we're going to talk about throughout this video, but we're going to use this position function. This is called a position function. Okay? We're saying that the x position of the object, the position of the object along the x-axis is a function of time. So really it depends on how much time has passed as to where the object is. And you can see here this says t to the 4th power minus 14t to the 3rd power plus 47t squared minus 10t minus 72. Okay? This is a polynomial function. It's a 4th power polynomial function. And having t's here instead of x's, that's just fine. It doesn't matter. Okay? It's just now x is the output value and time is the input value. Okay? Now what I recommend you do, you're probably going to need, in fact I'm going to tell you, you are going to need a TI-84 or any kind of graphing calculator. You could use Desmos also if you wanted to, but you're going to need some kind of calculator to be able to key this in and do some calculations. Okay, so get a graphing calculator or open up Desmos. Here's what you're going to do. These TI-84 calculators, they do not recognize the letter T as an input unless you're in parametric mode, but we're not going to use parametric mode. So when you press, look at this, when you press y equals to key in a function, you're going to use the letter x everywhere you see a t. So instead of keying in t to the 4th power, I'm going to key in x to the 4th power. So I'm going to go x to the 4th power minus 14x to the 3rd power x to the third power plus 47x squared minus 10x minus 72. And it doesn't really matter. I'm still going to get the same output values. It's just that this calculator only works in x as an input and y as an output, even though in this case we have t as an input and x as an output. It's not flexible in that way. Okay? So now what I'm going to do is I'm going to press the graph button. And it's going to draw a graph, and it's going to look kind of weird. Really, you're just going to see some lines on there. But that doesn't matter because we don't have to see the graph. We're not working with the graph today. We're just working with calculations. Okay? Well, we won't need this for just a little while. To answer the first couple questions, we will not need the calculator. Let's look at this first question. It says, and this will oftentimes, probably always be the very first question that you are asked in a calculus class when learning about rectilinear motion. The question is, what is the velocity of the object at time t? And the velocity of an object at time t, it's not saying at time t equals 7. It's saying just at time t, for any t. It's asking you for a velocity function. We have a position function, so we want to identify a velocity function. Well, this is really easy to answer because you already know how to do calculus. And the answer to this question is a calculus answer. The velocity, or v of t, velocity over time, v of t, is the derivative. The derivative. You probably already knew that was coming. Is the derivative of position. So if you have a position function, then v of t is just the derivative of the position function. Okay, so we're going to say v of t in this case equals, well, what's the derivative? And the reason it's the derivative is because velocity is the rate of change in position. It is the position over time. It's the change in position over time, okay? Or distance over time. So now, the derivative here, the derivative of t to the fourth is 4t to the third. So the velocity is 4t to the third power minus 3 times 14, that's 42. So minus 42t squared. Remember, our power goes down by 1. Plus 2 times 47, that's 94. So plus 94t. And then the derivative of negative 10t is just negative 10, right? Minus 10. And so now what we have is the velocity function. And the velocity function is 4t to the third minus 42t squared plus 94t minus 10. That is the velocity of the object at any time. So you could just key in any number. You could key in t equals 7. You could key in t equals 3. In fact, let's do that. We'll go ahead and grab the calculator. And what we're going to do is, watch this. In the calculator, we're going to turn off this function. The way we're going to turn it off is we're going to highlight. We're going to go on top of the highlighted equals sign, and we're going to press equals. Or sorry, not equals. We're going to press enter. And then watch now. See how it's not highlighted anymore? That means we've turned it off. Now if we hit graph, it's not going to graph the function at all. All right? But under y2, we're going to key in the velocity function. So we're going to put in 4t or 4x to the third power minus 42x squared plus 94x minus 10. And now if we press graph, we will see the graph of velocity. Let's see if it comes. There it is. There's the velocity. And now, let's say we want to know what is the velocity of the object. Let's say at time at how about v of 6? What is the velocity at time 6? Well, all we have to do now is press trace, and then key in 6, and press enter. And it tells us that when x is 6 or t is 6, velocity is negative 94. So we'll say v of 6 is negative 94. And it's that easy. So the velocity of the object at time 6 is negative 94. And we would probably have units on here. Let's say we were told that this was in meters. Let's say that this was in meters. And the time variable, let's say, is seconds, well, then velocity would be in meters per second. Okay? And so then this velocity would be negative 94 meters per second. Okay? So the velocity, very simply, velocity is just the derivative of position. Well, if you understand that, well, then this next one's going to be really easy. What is the acceleration of the object at time t? Well, acceleration is the rate of change in velocity. It's the rate at which velocity changes. That makes acceleration the derivative of velocity. So, let's see here. We will say a of t, which is acceleration, is the derivative. It's the derivative of velocity. That's easy enough. So that means that the acceleration of this object at any time t, is we're going to call it a of t. A of t is the derivative of velocity. 3 times 4 is 12. So 12 t squared minus 42 times 2, that's 84. So minus 84 t, and then the derivative of 94t is just plus 94. And of course the minus 10, that's a constant, so its derivative is 0. Now, because this is in meters and because our time variable is seconds, acceleration is always time squared. And so the units here are going to be meters per second squared. Meters per second squared. Okay? Now, if you want to try and understand that as best as possible, you may want to look up a video from physics or another video from calculus and try and understand why is acceleration meters per second squared. I could do another video later explaining using derivative notation why it's the derivative or the time value squared. But for now, just understand acceleration is meters per second squared. Or it could be feet per minute squared or miles per hour squared, something like that. Okay? All right, so that's two things. So now what if we ask the question, hey, what is the acceleration of the object at time 3? Okay, well, acceleration at time 3, we could write a of 3 equals, well, what I would do is I would want to put this acceleration function into the calculator. So I'm going to press y equals, and watch what I'm going to do. I'm going to turn off the velocity function. I'm going to go on top of the equal sign and press enter. Then I'm going to go down, and you can see now that the equal sign on the second function is not highlighted. That means it's turned off. So if I hit graph, it wouldn't graph it. Now I want to key in the acceleration function. 12t, but I'm going to press x, 12x squared minus 84x plus 94. Okay, so I went ahead and put that in. I'm going to hit graph. And now what it's going to do is it's just graphing the acceleration function. And now I can press trace, and it says what's the acceleration at time 3, right? So I'll key in 3, enter, and it says when x is 3, which is really time 3, this says y equals negative 50. That means acceleration is equal to negative 50. So the acceleration is negative 50 meters per second squared. Okay? All right, so we've answered 2 of our questions. How do we identify the velocity of an object? How do we identify the acceleration of the object? Now let's move on to question 3. Question 3 says, what is the speed of and direction? What is the speed and direction of the object at a specific time? All right, so let's talk about speed and direction. Speed and direction. Speed and direction are referring to velocity. See, velocity up here, velocity is a vector. Velocity is a vector. And in this particular case, what this means is this, is in a vector, the number and the sign both have specific meanings to them. Did you see up here how the velocity is negative 94? The 94 means one thing, and the negative means the other thing. And the way it works is this. The direction of the object is indicated by the sign of the object. Negative means the negative direction. Positive means the positive direction. The negative direction is leftward. The positive direction is rightward. That's in the x-axis. If it was the y-axis, positive velocity would indicate upward. Negative velocity would indicate downward. If it was the z-axis, positive would indicate forward, negative would indicate backward. And so the direction of the object is indicated by the sign. The number is called the magnitude of the velocity. So here, the velocity is negative 94. We have negative, that means a negative direction with a magnitude of 94. That 94 right there, that's the speed. So this object at time 6 is moving leftward at a speed of 94 meters per second. You want to be careful. Don't say that the speed is negative 94 meters per second, because speed does not have a sign to it. Speed is an absolute value. So speed is the number or the value. Okay? So if the question says, what is the speed and direction of the object at time 5, we need to go to the velocity function. We need to go to here. So what I'm going to do is I'm going to pick up the calculator and I'm going to press y equals. Currently, which function is turned on? The acceleration function is turned on. So we want to turn that off because I don't want to use acceleration in this question. So I'm going to go on top of the equal sign, press enter. Then I'm going to go up to the velocity function, go on top of the equal sign and press enter. And if I move over, you can see now that the equal sign is highlighted on the velocity function, so that when I press the graph button, I'm going to see the graph of velocity. Now, once that draws, I can now press trace, and I can enter 5. When I press enter 5, and press enter, it says that the output is negative 90. And so, here's what I'm going to write. I'm going to say that V of 5 equals negative 90, and therefore the object is moving left at 90 meters per second. Moving left at 90 meters per second. Now, if I give you a problem, if I don't give you units, then you just don't have to put the units. You could just say the object is moving left at 90, okay, or at a speed of 90, okay? So that's how you answer what is the speed and direction of the object at time 5. Let's look up another one. Let's say, what is the speed and direction of the object at time 1, okay? So we'll go here. We're still in trace. We'll press 1, enter, and what is the output there? It says the output is positive 46. So when V of 1 is 46, that means that the object is moving to the right because it's a positive number. The object is moving right at 46 meters per second. That's how we answer the question about speed and direction, okay, using velocity. All right, let's move on to question number 4 here now. It says, at what times t, that means there could be more than one. At what times t is the object at rest? Well, what does at rest mean? Well, at rest means something very specific in calculus. In not just calculus, but also in physics in general. The phrase at rest, let's fix that E right there. At rest means that velocity, v of t, equals 0. That means velocity equals 0. Because there's only 3 possibilities here for velocity. See how we said speed and direction? Velocity is either positive or velocity is negative, but there is a third possibility. What's between positive and negative? 0. So when the velocity is positive, that means that the object is moving to the right. When the velocity is negative, that means the object is moving to the left. But when the velocity is 0, that means that the object is at rest. At rest. So when we ask, at what times is the object at rest? Since at rest means that velocity is 0, what we need to do is we need to find the zeros or the roots of velocity. When does the velocity function equal 0? Well, we still have velocity in our function, right? Or in our graph. So all we have to do is identify what are the x values, or in this case, the t values. At what t values is this graph crossing over this horizontal axis? Those would be the zeros of velocity. And we can use the 0 feature in the calculator to be able to do this. You remember how to do that? We hit second and then trace, and that gives us the calculate menu. Then we go down to option 2, which says 0. So we're going to choose that. And then it says left bound. Well, it looks to me like the very first one is kind of near 0, right? So what I'm going to do is I'm going to enter -1 and +1 as my left and right bound. So it says left bound. I'm going to key in -1, enter. Then it says right bound, and I'm going to key in +1, press enter, and then it says guess, and I'm just going to press enter, and it says that there is a 0 at 0.1119, 0.1119. So I'm going to say that this object with this motion, it's at rest. One time it's at rest is when t is equal to 0.1119 seconds, right? Because this is in seconds. But let's look at this. There are 2 more zeros. There's one right here, and there's also one right here. So let's find out what those are. So we'll go back to second, trace, option 2, enter. Now this one here looks like it's somewhere around 1, 2, it's around 3. So I'm going to enter 2 and 4 as my left and the right bound. So it says left bound, I'm going to enter 2, enter. Right bound, I'm going to enter 4, enter. And when it says guess, I'm just going to press enter. It's going to think for a minute, and it tells me that one of my zeros is at 3.0398. 3.0398. And so, now I understand that the calculator says it's x equals, but I'm telling you it's because the calculator has a limitation. It's actually a t value. So we're going to say t equals at time. Well, the object is at rest. It's not moving at all. The velocity equals 0, which means its speed is 0, right? At 0.1119 seconds, also at 3.0398 seconds. All right, good. But there's one more on here. Look, there's one more 0. So we're going to do this again. Second, trace, option 2, enter. All right, this one looks like it's somewhere around, see, 3, 4, 5, 6, somewhere around 7. So I'm going to put in 6 and 8 as the surrounding value. So left bound, put in 6, enter. Right bound, we'll put in 8, enter. Then guess, we'll just press enter. Let's see what it gives us. It says that it equals 0 at 7.3483. 7.3483. I rounded that fourth number, okay? 7.3483. Well, and that's the last place where velocity crosses over the t-axis. So we'll say here, put it down here. T equals 7.3483 seconds. So we have identified all 4, that's an S, all three times when the velocity is equal to, so there's 3 times when this object is at rest. Okay? Now, do you see this right here? Do you see how it says negative 8 e to the negative 11? That basically means 0. It's just the calculator does an approximation, and when you see that, it basically means 0. Okay? All right. Let's see what we can do here. Last question. We've answered 4 very important questions. The last question we're going to answer is the object speeding up or slowing down at time 3 seconds? All right, let's talk about this for a minute. It's going to take a few minutes to talk about. What does speeding up and slowing down mean? Well, there's a couple ways of understanding this. Think about it this way. When an object is in motion, it's always slowing down right before it stops. Right before the velocity is equal to 0, it's slowing down. It's not possible for an object to speed up without slowing down and then stop. And you might say something like, well, what about like when something's falling off of a building? It's speeding up because of gravity, right? And then it hits the ground and stops. I see what you're saying there, but I want you to consider this. When it makes contact with the ground, I know it seems like that moment is instantaneous, but in reality, there is a lot happening in that 1/10 of a second. And what's happening in that 1/10 of a second is the object is slowing down before it stops. And sometimes it slows down so fast with so much impact that it actually bounces off the ground. So it stops, then it starts back up again in the opposite direction. Like a penny falls, then hits the ground and bounces up. Well, it can't change direction without stopping. What's happening in that 1/10 or 100th of a second is the object is slowing down really, 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 really fast. But it is slowing down before it stops. So, before an object stops, it always slows down. Also, when an object is stopped, it can't start moving without speeding up. And what I mean by this is an object always speeds up by moving away from at rest. And an object always slows down right before it is at rest. So when the object is moving toward the t-axis, when the velocity of the object is moving toward the t-axis, the object is slowing down. When the velocity of the object is moving away from the t-axis, the object is speeding up. But I'm going to give you a much simpler mathematical way of understanding whether the object is speeding up or slowing down. And here's how it goes. It has to do with velocity and acceleration. We need both of these functions. Here, I'm going to clean up some of this. I'm going to erase a bunch of these answers so that we're less cluttered up here. All right, let's erase that. Okay, that's pretty good. All right, so look, see velocity and acceleration? Here's the thing. Acceleration influences velocity the same way that velocity influences position. When velocity is negative, the object is moving in a negative direction. The position is becoming more negative. When velocity is positive, the position is becoming more positive. It's the same thing with acceleration. If velocity is already positive, moving in a rightward direction, not necessarily in a rightward position, but moving in a rightward direction. Wait, actually that's the other direction, right? There we go. Okay. Moving in a rightward direction. Velocity is positive, right? If acceleration is also positive, then basically it's influencing velocity to be more positive. So if velocity is positive 10 and acceleration is positive, it's going to push velocity to become positive 11, positive 12, positive 13, which means that the speed is getting larger. That is speeding up. And here's what that means, is that when velocity and acceleration are both positive, the object is speeding up. Similarly, let's say the object is moving in a negative direction. That means velocity is negative. Let's say velocity is -5. So the object is moving in a negative direction. Also, let's say acceleration is negative. That means acceleration is influencing velocity to stay negative and become more negative. Moving in a negative direction and becoming more negative. So that means velocity is going from -5 to -6 to -7 to -8. And even though the value of velocity is getting smaller because it's a negative number, the magnitude, the speed, the magnitude is getting larger. The absolute value of -5 is 5. The absolute value of -6 is 6. The absolute value of -7 is 7. And so the speed is actually getting larger and larger and larger. So when velocity is negative and acceleration is also negative, the object is going to speed up in the opposite direction, in the negative direction. So here's what I mean by that. Whenever velocity and acceleration have the same sign, if they are both positive or both negative, then the object is speeding up. On the other hand, the opposite is also true. If velocity is positive, meaning the object is moving in a positive direction, but if acceleration is negative, it's pushing back on velocity. So if velocity is 10 and acceleration is negative, that means that velocity is going to go from 10 to 9 to 8 to 7 to 6. Velocity, the magnitude, is getting smaller, and therefore the object is slowing down. So whenever velocity is positive but acceleration is negative, then the object will be slowing down. Velocity will be getting closer to 0. Similarly, if the velocity is negative, meaning the object is moving in a negative direction, but acceleration is positive, if the velocity is -5 and acceleration is positive, then eventually the velocity is going to go from -5 to -4 to -3 to -2 to -1 and then 0. That means the object is slowing down. So here's your rule. For the question of speeding up and slowing down, if velocity v of t and acceleration a of t have the same sign, either both positive or both negative, the object is speeding up. The object is speeding up. On the other hand, if velocity and acceleration, if velocity v of t and acceleration a of t have different signs, one of them's positive and one of them's negative, have different signs, then the object is slowing down. Or we'll just say the object is slowing, oops, put the S in. The object is slowing down. So all we have to do to find whether the object is speeding up or slowing down at time 3 is we'll get our calculator out, find out what velocity is at time 3, find out what acceleration is at time 3, and see if they have the same sign. So we want to know what is velocity at time 3 and what is acceleration at time 3. And I can do that with the graphing calculator. Currently, the second function is turned on. That's velocity. And I usually put position, velocity, acceleration in when I put them in the calculator. So look, I'm going to hit graph. I'm going to press trace. Then I'm going to press 3, enter. And it says at time 3 that the velocity is positive 2. So, at time 3, velocity is positive 2. Now I'm going to turn off the velocity function and turn on the acceleration function. So I'm going to go to y equals. I'm going to go down over here to the equal sign. I'm going to press enter. That's going to turn off velocity. Then I'm going to go on the equal sign for acceleration, press enter, and that's going to turn on acceleration. Then I'm going to press graph, and now we're going to see the acceleration graph. Good. And now we're going to hit trace, and we're going to press 3. I'm going to key in 3, enter over here, and it says that when at time 3, the output is negative 50. Negative 50. So that means acceleration at time 3 is negative 50. And because one of them is positive and one of them is negative, at time 3, this object is slowing down. And that's all I have for you. Why don't you take the work that I've given you, the worksheet, or find some other problems. Hopefully this is really helpful to you. This is just the very beginning of understanding object motion. Once you understand this, in the next class, I can teach you even more about how objects move. We can do optimization problems. We can identify maximum velocity, minimum acceleration. We can find out when the object is farthest to the left, or farthest to the right, or how far left the object goes, how far right. When does the object achieve maximum velocity? And these are important questions, especially for engineers, okay? All right, we'll practice this up. You should be in good shape, and I'll see you in class.